right, so we're looking at that example question, so let's go ahead and take a read of it. A block of ice with a mass of 2.5 kilograms is moving on a frictionless horizontal surface. At t equals 0, the block is moving to the right with a velocity of magnitude 8 meters per second. Calculate the magnitude and direction of the velocity of the block after each of the following forces has been applied for 5 seconds. A force of 5 newtons directed to the right and a force of 7 newtons directed to the left. So we have our 2.5 kilogram mass. It's moving to the right at 8 meters per second. I'm going to define the right as my positive direction, to the left as my negative direction. Next, I'm going to be using the impulse momentum theorem. Now, the impulse momentum theorem is all these parts. So how do I know how to use it? Well, what I do is I look at what information they gave me, and I pick parts based on that information I was given. So I was given things like mass and velocity. So that means I'm going to pick this part. I was given things like time and force, so this part. And so I take the two parts that meet the information and the stuff I'm trying to find, and I put those two parts together. Now I have my equation I can use. So my 5 newtons to the right, I labeled it as positive, plugged in my numbers into my equation, solved for the velocity. I got a positive velocity out, which means it's to the right. So I have to be explicit about that direction. So I'm going to say 18 meters per second to the right. The positive 18 isn't good enough. For part B, we had that negative 7 newtons for our force because the force was to the left. Plugged in my other information, solved for my final velocity. I got negative 6 meters per second. The negative is not good enough. I have to state 6 meters per second to the left. And there's our example.